Hello everyone. Today we're going to do another AMC problem. Is the 2014 AMC 12B number 15. So it's kind of in the middle, and it's one of those questions that, kind of make it or break it if you get into the AIME or not. So here it is. Now, before I do this, I just want to say one thing. I'd say the biggest problem with students who almost make it into the AIME but just don't is that they are too scared of just working like a little bit with the problem. They expect to get an answer right away, and if they don't, they get discouraged. Well, don't do that. Usually, you in these later AMC problems, you're gonna have to mess around with the question a little bit before you understand it. So here we see that P is this sum right here, the sum that we don't necessarily understand all that much about. And then we have to take e to the power of this sum right here. And it's saying that it's an integer. And now we're going to have to take the largest power of 2 that's a factor of... Okay, so one step at a time. First, let's just look at this sum right here. Now, I'd say the easiest part about this question is that it doesn't go from 1 to like 100. It just goes from 1 to 6. So because of that, all we have to do pretty much is list out the whole sum. We can do that. So let's see, it's going to be 1 times ln of 1 plus 2 times ln of 2 all the way to 6 times ln of 6. Let me just write it over here. So it's 1 times ln of 1 plus 2 times ln of 2 plus 3 times ln of 3 plus 4 times ln of 4 plus 5 times ln of 5 plus 6 times ln of 6. That huge sum, right? Well, it's not even huge. It's just 6 terms. And now we just have to take e to the power of this number right here. So let's just put an e over here. So e to the power of this whole sum. Now let's just simplify this a lot. So what can we do first? Well, the first thing we can do is that we realize that e to the power of something plus something is equal to e to the power of that one thing times e to the power of the other. That's just a basic exponent law. The idea that x to the power of a plus b is equal to x to the power of a times x to the power of b. Just a normal standard law of exponents. So let's just do that here. We got e to the power of 1 times ln of 1 times e to the power of 2 times ln 2 times e to the power of 3 times ln of 3, and I'm not going to write the rest. You get the idea. So now, what can we do with this? Well, what you should do now is that realize that if you take e to the power of ln of whatever, that number is going to come down. So say I have a to the power of log base a of 10. Because of standard logarithm rules, if the base of this logarithm is the same as this base number, then that means that this logarithm and this number a is going to cancel, and this 10 is going to come down. So a to the power of log base a of 10 is just equal to 10. So now what? Well, we can take this right here. Remember, ln is just a log base e. So e to the power of 1 times ln of 1, if we just cancel the ln and the e, is just 1 to the power of 1 right here. And we could do that over here. So we got e to the power of 2 times ln of 2. The e cancels out, and the ln cancels out. So now, and then you bring the 2 back over here. So you have 2 to the power of 2. So you got 1 to the power of 1 times 2 to the power of 2 times, let's do it one more time. The e cancels out, ln cancels out, and then you take this 3, put it back in place where the e is, so you have 3 to the power of 3. The 3 on top is still left over. So you got 1 to the power of 1 times 2 to the power of 2 times 3 to the power of 3 times 4 to the power of 4 times 5 to the power of 5 times 6 to the power of 6. So this is the value of p, simplified down to this. So what were we trying to find again? Let's see, what is the largest power of 2 that is a factor of e to the power of p? Okay, so, oh, and sorry, I said that this was p. No, this is e to the power of p. The simplified version of e to the power of p, not just p itself. So now what we're just trying to find is the largest power of 2 that's a factor of e to the power of p. Well, That basically just means that if we take the prime factorization of this and we take the power of 2, then we get our answer. Because remember, when we take a prime factorization, we're taking all the powers of the primes and we're writing those down. So the largest power of 2, that is a factor of e to the power p, would just be the prime factorization of this term and looking at the powers of 2. So let's do that. Let's just prime factorize this to find the powers of 2. So let's see, there are 2 powers of 2 obviously here. So it's 2 to the power of 2 at least. Let's see, are there any powers of 2 and 1 to the power of 1? No, of course not. Let's see, 3 to the power of 3. Well, if you simplifying, this is already completely simplified, so there are no 2's in 3 to the power of 3. 2 doesn't divide 27, see? 3 to the power of 3 is 27, 2 doesn't divide 27. So, let's see, 4 to the power of 4. Well, keep in mind, 4 is just 2 squared, right? So 4 to the power of 4 is just 2 squared to the power of 4. And 2 squared to the power of 4 multiplied the 2 exponents together is 2 to the power of 8. So there are 8 more 2's right here. Let's see, 5. Well, no, there are no 2's in 5 because 5 is a prime number, so there are no factors in 5. And finally, 6. Well, 6 is just 2 times 3. We don't care about the 3's, we just care about the 2's. So when we take this to the power of 6 exponent, 6 to the power of 6 in its prime factorization form is just 2 to the power of 6 times 3 to the power of 6, but we only care about the 2 to the power of 6. So we add 6, and that's it. 2 to the power of 2 plus 8 plus 6, or 2 to the power of 16. This is the largest power of 2 that is a factor of e to the power of p. That is the answer. Now again, just to reiterate, don't be afraid to just dive into the question, simplify some stuff, and in future ones we're going to do questions where we test out a few things and it just doesn't work. But that's how it is. They expect you to not get it right away. They don't expect you to get it right away at the first time all the time. So the lesson is to just make sure that you aren't too scared to look into things, and don't be afraid to be wrong, because you do have a lot of time on the AMC. You might not think that's a lot of time, but it's enough time to learn about the question. So, thanks for watching.